Hello students, welcome back to the session of Laws of Motion, part 9.
In today's class, we are going to study the continuation part of part 8, which we have studied in the last class. Those whoever has not yet watched the part 8 of Laws of Motion, please go and watch that part and watch this part of Laws of Motion so that you will understand clearly. So let's go for the second kind of friction, that is kinetic friction. Kinetic friction is the second kind of friction. Is it clear? So let's go for the definition of kinetic friction and let's understand what is the kinetic friction. The definition of friction is the opposing force which comes into play when one body moves over the surface of another body. So here you have to understand clearly. Again, the kinetic friction by the name itself indicates friction means opposing force. Yes, the friction means opposing force. And here by the word kinetic, which indicates motion. Okay, so whenever you study any of the topic, please try to understand the meaning of the concept. Friction means opposing force and kinetic means motion. So here what is kinetic friction? The friction which comes into play when the object is in motion. This is the rough meaning. So let's go for the meaning of the definition. The opposing force which comes into play. So here is a opposing force. It is coming into play when one body moves over the surface of another body. So if you consider here is a object, okay, and this is the surface. The friction will come into play in the case of kinetic friction only when this object starts to move. If the object is moving, then the opposing force whichever comes into play, to that opposing force only what we call it as kinetic friction. To that opposing force only what we call it as kinetic friction. Is it clear? We have studied about the static friction in the part 8 of laws of motion. As we have discussed in the last part of laws of motion, the kinetic friction is coming into the play only when after reaching to the maximum value. That is also we have discussed using the graph. So again let's recall that if you consider here is an object which is on the surface. So you apply the force here towards rightwards. When you are applying the force, then what will come into the play? The friction will come into the play. When the object is into the motion, I mean impending motion, the whatever the force will come into the play, to that what we call it as static friction. Okay now, so here we are going on increasing the friction. If we apply 1 Newton friction, there is a opposing force by 1 Newton. If we apply 2 Newton force, and there is a opposing force by 2 Newton. So if we go on increasing, let's consider if I apply 2.5 Newton, this friction may also develop 2.5 Newton. And next what I will do, I will apply 2.6 Newton, but this friction may fail to develop the 2.6 Newton, and hence this is the applied force is greater than this opposing force. Then to this only what we call it as maximum static friction, which we have discussed in the last class. Then what happens? This object starts moving. Then when the object starts moving, whichever the force comes into play, to that only what we call it as kinetic friction. That you can see in the animation clearly so that you will understand.
So here is an animation in which you can observe clearly. The box is at rest on the table. When you apply the certain force, and that force should exceed the maximum static friction. When it exceeds the maximum static friction, then the object starts to move. When the object starts to move, the force which comes into play oppositely to that force, what we say it as kinetic friction. You can observe clearly here, there is a push by 2 Newton and it is increased by 2.5 Newton to 2.6 Newton. But there is an opposing force which is stopped at 2.5 Newton. When the opposing force is stopped at a 2.5 Newton, to that 2.5 Newton only what we call it as maximum static friction, which we have studied in the last part. So after exceeding the maximum static friction, if you apply more force, that is 2.6 Newton, then the object starts to move. So that object start to move means it is come into the motion. when it has come into the motion, the opposing force which is coming into play on the object, to that force only what we call it as kinetic friction. Is it clear? I hope you have understood the definition of a kinetic friction. Here you can see one more animation in which scale reading is clear. Here we will pull the object towards right until when? Until to the certain newtons. You can observe we are pulling the object till to the 1 Newton. Okay, so when the object is pulled till to 1 Newton, then what happened to the object? Object started moving. Before 1 Newton, did the object move? No. Why did not the object move? Because there was a static friction. After reaching to the maximum value, then only what happened to the object? Object started to move. Is it clear? Now you have to understand, when the object started to move, the opposing force which is acting on that object, to that only what we call it as kinetic friction. Is it clear? I hope you have understood the concept of kinetic friction. Now let's see how we denote the kinetic friction.
Kinetic friction is denoted by Fk. F stands for friction, K stands for kinetic, so it indicates kinetic friction. Is it clear? And this kinetic friction is also called as sliding friction. Okay, sliding friction in the sense what we that if we take this is the object, if we consider this is the object, if we slide like this, then what is it? It is into the motion. So however the object is in motion, but it is sliding on the surface. So to that also what we call it as sliding friction. Is it clear? So what we say, kinetic friction is also called as sliding friction. So let's go for the characteristic. The first characteristic of a kinetic friction is it is independent of area of contact. Even in the case of static friction, it was also having the same characteristic. Means kinetic friction is not depending upon the area of contact. For example, if I consider the object and if I place it on any of the table, whatever the area it is in contact with the surface, so it is not bothering about the area of contact. It is means what? The kinetic friction will not bother about the area of contact. Whatever the area of contact, the kinetic friction will be present. If you consider this large surface, here is a large area which is in contact with the table. It also will be getting the same kinetic friction. So what we say? Kinetic friction is independent of area of contact. Is it clear? Okay, let's go for the next characteristic. So the next characteristic is it is nearly independent of velocity of moving bodies. Means the kinetic friction is independent of velocity of moving bodies. When it will be independent? Only when the moving bodies are having less velocity. So if the moving bodies are having less velocity, then the kinetic friction will be independent of velocity of moving bodies. So only what we have written here, nearly independent. If the object is moving with a very low velocity, then only kinetic friction will be independent of its velocity. Is it clear? So let's see the next characteristic, that is the magnitude of kinetic friction Fk varies with normal reaction. The magnitude of kinetic friction Fk varies with normal reaction. So Fk is varying with normal reaction. How is it varying? It varies in direct proportionality. Is it clear? Then how does it vary? If kinetic friction is more, normal reaction will be more. If kinetic friction is less, normal reaction will be less. Is it clear? So now let's see the law of kinetic friction. As I told, the kinetic friction varies with normal reaction. How it varies? It varies in direct proportionality. If you remove this proportionality constant, you have to introduce a constant term. To that what we say it as mu k. Okay, and as I have introduced, let me write remaining data Fk. If as I introduce this mu k, I will write the is equal to symbol and n. Okay, so Fk is equal to mu k into n is the law of kinetic friction, where mu k is coefficient of kinetic friction and N is normal reaction. Okay, and N is normal reaction. Is it clear? And again, this coefficient of kinetic friction is depending on certain factors. So let's see factors affecting on coefficient of kinetic friction. The first factor is nature of the two surfaces in contact. So this is very important. What is the kind of nature which is in contact with the surface of the another body? So if you consider here is a box, and this box, let me consider it is on the table, and the same box I will consider it on a sand road. This is a muddy road, you can consider. So this is muddy and this is table. Okay, so where you can move the object easily, you just tell me where you can move the object easily. Of course on the table. Why it is on the table? Because comparatively to the muddy surface, the table offers smooth surface. As the surface is smooth, the frictional force acting on the object will be less. And what kind of friction? That is coefficient of kinetic friction. So coefficient of kinetic friction will be less in the smooth surface and it will be high in the muddy surface. Muddy surface indicates what? Rough surface. Is it clear? So by that what we can say, the coefficient of kinetic friction changes according to the surface in contact. If the surface is rough, the coefficient of kinetic friction will be high, and if the surface is smooth, the coefficient of kinetic friction will be less. That's what I have shown you in the last part of friction, in which a man was walking on the sand. And I told you that we experience a difficulty to walk on the sand road than comparative to the normal road. What is the reason? The reason is because of the coefficient of kinetic friction. So coefficient of kinetic friction depends upon the nature of the two surfaces in contact. Is it clear? Next factor is depending on the nature of the materials in contact. Nature of the two materials in contact. This friction also depends upon the nature of the material. This object which is placed on the contact, so this material and this material, both the materials will also affect on the coefficient of kinetic friction. Is it clear? I hope you have understood the factors affecting on the coefficient of kinetic friction and also law of kinetic friction. So using the law of kinetic friction, we will define coefficient of kinetic friction. So coefficient of kinetic friction is defined as the ratio of kinetic friction on a body to the normal reaction. So we can just make the formula just using this definition, and this definition is made using the law of kinetic friction. What is the law of kinetic friction? Fk is equal to mu k into n. So Fk is equal to mu k into n. Using that, I want to know the definition of coefficient of kinetic friction. So keep the coefficient of kinetic friction here itself and send the normal reaction to the denominator of this Fk. Then what it will become? Fk divided by n, which even we can write it as mu k is equal to Fk divided by n. So you can just make the definition using the formula. Mu k is coefficient of kinetic friction, is equal to indicates is defined as, and as it is in the numerator and denominator form, we will use the ratio term. Fk is kinetic friction, n is normal reaction. So we will define the coefficient of kinetic friction now. Coefficient of kinetic friction is defined as the ratio of kinetic friction to the normal reaction. So this is the definition of coefficient of kinetic friction. That's what we have written here. And what is the formula of coefficient of kinetic friction? The formula of coefficient of kinetic friction is mu k is equal to Fk divided by n. Is it clear? I hope you have understood this coefficient of kinetic friction. So now we will go for the motion of a body by considering the kinetic friction. What happens to the motion of a body if we consider the kinetic friction? So let's go for that. Case 1, when applied force is greater than the kinetic friction. When applied force is greater than kinetic friction, then what happens to the motion of a body? So what we write here, force applied is greater than Fk. When the force applied is greater than Fk, then what happens to the total force? The total force is denoted by F net. Okay, na? Using the Newton's second law, we write the total force is equal to mass into acceleration of the body. Is it clear? And the total force here, what we can write? The total force is force applied minus kinetic friction Fk. Why it is minus Fk? As it is less than force applied, we can write it as force applied minus Fk, which is equal to m into a. Then what happens to the motion of a body? Motion of a body we can decide using the acceleration. Therefore, acceleration a is equal to, then send this m to the denominator of this new left hand side, then what it will become? Fa minus Fk divided by m. So this is the acceleration of a body. So in case of this, if the force applied is greater than Fk, then what happens to its velocity? Velocity will be increased. Velocity is increased. Is it clear? So the velocity of the body will be increased, and hence what it will be having? It will be having positive acceleration. It will be having positive acceleration. Is it clear? So let's go for the next case. Case 2. When the applied force is equal to kinetic friction. So what it indicates? When the applied force is equal to kinetic friction, in the sense we can write it as Fa is equal to Fk. Okay, so when it is Fa is equal to Fk, then what happens? The total force F net will become 0. Why net force? I mean total force will become 0. If the value of force applied is equal to the force of kinetic friction, both of them will be cancelled, then total force will become 0. Is it clear? Let's use the second law. What is it? F net is equal to mass into acceleration. Since the total force is 0, we write here the value is 0, which is equal to m into a, and 0 by anything is 0. So if you cross multiply this m, then what happens? A is equal to 0, and hence what we got? Acceleration is 0. Acceleration is 0 means what? A is equal to constant. Then how the body is moving? The body is moving with a constant acceleration. If it is moving with a constant acceleration, we can say that the body is moving with uniform velocity. It is moving with uniform velocity. Is it clear? I hope you have understood. Let's go for the next case. So case 3, when the applied force is less than the kinetic friction. So here what is that? Force of applied is less than kinetic friction. Means if you consider this object, whatever the force you apply, no, that is very less as by compared to this opposing force. ಅಂದರೆ ನೀವು ಹಾಕ್ತಾ ಇರುವಂತಹ ಫೋರ್ಸ್ ಏನಾಗಿದೆ ಅಲ್ಲ ಈ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ, ಅದು ಕಡಿಮೆ ಇದೆ ಕಂಪ್ಯಾರಿಟಿವ್ ಟು ದ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಆವಾಗ ಏನಾಗಿರುತ್ತೆ? ವೆನ್ ದ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಈಸ್ ಲೆಸ್ ದೆನ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್, Fa is less than Fk, or Fa is equal to 0. Both the conditions gives the same result. So to calculate the value of acceleration, we will use the same formula which we have used in the case 1, which is A is equal to Fa minus Fk divided by m. Okay. As by the statement, applied force is less than kinetic friction. If Fa is less than kinetic friction, then what happens? Then the answer is A is equal to minus Fk divided by m. We will get minus Fk. Okay, for example, if you consider force applied is equal to 2 Newton and kinetic friction is 3 Newton. Substitute in the formula, A is equal to 2 minus 3 divided by m. Therefore, what we got the answer? Minus 1 divided by m. So this minus indicates what? This minus indicates negative acceleration. Negative acceleration means the body is moving with decreasing velocity. The body is moving with decreasing velocity, and hence decreasing velocity is called as retardation. Is it clear? If the applied force is less than kinetic friction, we can say that the body is moving with decreasing velocity. And even same condition holds for if the applied force is equal to 0. If the applied force is equal to 0, what happens? This force applied will become 0, and hence what is the answer? A is equal to minus Fk divided by m. I hope you have understood the concept of motion of a body by considering the kinetic friction. Now we will go for the comparison between kinetic friction and now we will see the comparison between Fs and Fk. Fs stands for static friction and Fk stands for kinetic friction. Okay, so let's see what is the comparison. Coefficient of kinetic friction is always smaller than the coefficient of static friction. This is very important. Okay, here what they are saying, coefficient of kinetic friction, which is mu k, is less than mu s, coefficient of static friction. Then why is it coefficient of kinetic friction is less than the coefficient of static friction? That's what we had seen. Whenever the object is coming into the motion, when it is coming into the motion after exceeding the maximum static friction, right? So when it is coming into the motion, whatever the opposing force will be there, to that what we call it as kinetic friction. And at that time, when you compared how much of force you have applied when the object was into the motion, and at that time the opposing force was static friction. So ಯಾವಾಗ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ನೀವು ಏನು ಫೋರ್ಸ್ ಹಾಕಬೇಕಾಗುತ್ತಲ್ಲ ಅದೇ ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ, ಯಾಕಂದ್ರೆ ಅವಾಗ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಜಾಸ್ತಿ ಆಫರ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಒಂದ್ಸತಿ ನೀವು ಮ್ಯಾಕ್ಸಿಮಮ್ ಲಿಮಿಟ್ನ ಕ್ರಾಸ್ ಮಾಡಿಬಿಟ್ಟು ಮೋಷನ್ಗೆ ಬಂದಾಗ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಆವಾಗ ಈ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ನು ಇರುತ್ತೆ, ಬಟ್ ನಮಗೇನಾಗಿರುತ್ತೆ ಕಂಪ್ಯಾರಿಟಿವ್ಲಿ ಟು ದ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಇಟ್ ವಿಲ್ ಬಿ ಲೆಸ್. ಆಸ್ ವಿ ನೋ ಮ್ಯೂ ಕೆ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಕೆ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್, kinetic friction divided by normal reaction, and mu s is equal to fs divided by n. So we will substitute these values into this equation. So what happens, let's see. Fk divided by n is less than Fs divided by n. So n in the denominators get cancelled each other. Therefore what we get, kinetic friction is less than static friction. So this is the relationship between kinetic friction and static friction. So always kinetic friction is less than the static friction. So to make you understand clearly, I will show you an animation so that you will get an idea.
So here is an animation which shows both static friction and kinetic friction. You can see here, ಈ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಲ್ಲಿ ನೀವೇನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ರಲ್ಲ ಫೋರ್ಸು, ದಟ್ ಈಸ್ ಓನ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್. ಯಾಕಂದರೆ ಅಲ್ಲಿ ನಿಮಗೆ ಅಪೋಸಿಂಗ್ ಫೋರ್ಸ್ ಏನಾಗಿರುತ್ತೆ ಜಾಸ್ತಿ ಆಫರ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಸೊ ನೀವು ಈ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ನೀವು ಫೋರ್ಸ್ ಹಾಕ್ತಾ 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 ಹೋದಾಗ ವೆನ್ ಯು ರೀಚ್ ಇಟ್ ಟು ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ದೆನ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಕಮ್ಸ್ ಇನ್ ಟು ದ ಮೋಷನ್. ಸೊ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದ್ಯಾಟ್ ಇನ್ ದ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ನೋಡ್ರಿ, ವೆನ್ it is into the motion, the boy is moving the object quite easily when you have compared to the static friction. So static friction ಅಲ್ಲಿ ನೀವು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಎಫರ್ಟ್ ಹಾಕಬೇಕಾಗುತ್ತೆ. ಅದೇ ಒಂದು ಸತಿ ಆಬ್ಜೆಕ್ಟ್ ಏನಾದರೂ ಮೋಷನಲ್ಲಿ ಬಂದ ತಕ್ಷಣ ನಿಮಗೆ ಅಪೋಸಿಂಗ್ ಫೋರ್ಸ್ ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಸೊ ದ್ಯಾಟ್ ಯು ಕ್ಯಾನ್ ಮೂವ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಈಸಿಲಿ ಹಿಯರ್. ದಟ್ಸ್ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಇನ್ ದ ಅನಿಮೇಷನ್. You can even imagine in your daily life. For example, if you are moving the object, ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ನ ತಳ್ಳಬೇಕಾದ್ರೂ ಕೂಡ ಸ್ಟಾರ್ಟಿಂಗ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗುತ್ತೆ, ಯಾಕಂದರೆ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಇರುತ್ತೆ. ಅದೇ ನೀವು ಸ್ವಲ್ಪ ಆಬ್ಜೆಕ್ಟ್ ಮೋಷನಿಗೆ ಬಂದ ತಕ್ಷಣ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಯು ಕ್ಯಾನ್ ಮೂವ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಈಸಿಲಿ, ಯಾಕಂದರೆ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ವಿಲ್ ಬಿಕಮ್ ಲೆಸ್ ಆಸ್ ಕಂಪೇರ್ ಟು ದ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ದಿಸ್ ಈಸ್ ವೈ ವಿ ಸೇ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಈಸ್ ಆಲ್ವೇಸ್ ಲೆಸ್ ದ್ಯಾನ್ coefficient of static friction. Is it clear? So I hope you have understood the comparison between the static friction and kinetic friction using this animation clearly. Now let's go for the next kind of friction.
So now we'll go for the third kind of friction, that is rolling friction. By the name itself indicates roll. Roll means what? It will be rolling on the surface. The point of object which is in contact with the surface ಏನಾಗುತ್ತೆ ಅದು ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ನಾವು ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ, ರೋಲಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಲೆಟ್ಸ್ ಸಿ ದ ಡೆಫಿನಿಷನ್. The force of friction which comes into play when one body rolls over the other surface. So here you have to understand this word. Rolls in the sense what? If you consider here is a object, right? So if it is rolling on the surface means what? Here it is in contact. This point is in contact with this surface. ಅಂದರೆ ಈ ಪಾಯಿಂಟ್ ಏನಾಗಿದೆ ಸರ್ಫೇಸ್ ಜೊತೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ರೋಲ್ ಆಗಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್, ಇಫ್ ಇಟ್ ಈಸ್ ರೋಲಿಂಗ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ, ದಿಸ್ ಪಾಯಿಂಟ್ ವಿಲ್ ಕಮ್ ಇನ್ ಟು ದ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಸರ್ಫೇಸ್. ಇದೇನಾಗುತ್ತೆ, ಈ ಪಾಯಿಂಟ್ ಮೇಲೆ ಹೋಗ್ಬಿಟ್ಟು ದ ಅನದರ್ ಪಾಯಿಂಟ್ ವಿಲ್ ಕಮ್ ಇನ್ ಟು ದ ಕಾಂಟ್ಯಾಕ್ಟ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಅಗೇನ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ದ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಗೋಸ್ ಆನ್ ಚೇಂಜಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಯು ಸೇ ದಿಸ್ ಈಸ್ ಪಾಯಿಂಟ್ 1 ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ಪಾಯಿಂಟ್ 2, ಹಿಯರ್ ಪಾಯಿಂಟ್ 1 ಏನಿದೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇದೆ, ನೆಕ್ಸ್ಟ್ ರೋಲ್ ಮಾಡಿದಾಗ ಪಾಯಿಂಟ್ 2 ಕಾಂಟ್ಯಾಕ್ಟಲ್ಲಿ ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ರೋಲ್ ಮಾಡಿದಾಗ ಪಾಯಿಂಟ್ 3 ಕಾಂಟ್ಯಾಕ್ಟಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ನೀವು ಇಲ್ಲಿ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಿದ್ದೀರಿ, ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ ಸರ್ಫೇಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವಾಟ್ ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಸೇಸ್, ದ ಫೋರ್ಸ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ವಿಚ್ ಕಮ್ಸ್ ಇನ್ ಟು ಪ್ಲೇ ವೆನ್ ಒನ್ ಬಾಡಿ ರೋಲ್ಸ್ ಓವರ್ ದ ಅದರ್ ಸರ್ಫೇಸ್. ಸೊ ಇನ್ ದಿಸ್ ಕೇಸ್ ಆಫ್ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, the rolling friction is smaller than kinetic friction and static friction. So what we can write? We can write Fr. Rolling friction is denoted by the symbol Fr is less than Fk, and this kinetic friction is less than static friction. So overall what we can say, rolling friction is less than kinetic friction, rolling friction is less than static friction. So what we write, therefore the rolling friction is less than kinetic friction and it is less than static friction. So compared to kinetic friction and static friction, rolling friction is very smaller. ಈ rolling friction, why the rolling friction is smaller? Let's see here. See what happens in case of a kinetic friction or static friction. If you consider this is the object, okay na? So this is the object and here is the area of contact. So when you push this object with certain force, ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಇಲ್ಲಿರುವಂತಹ molecules or atoms, they will rub with the molecules of the surface in contact. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ರಬ್ ಆದಾಗ the motion will not be easier. As they rub each other, then what happens, friction will be more. ಒಂದು ವೇಳೆ ಇದೇ ಆಬ್ಜೆಕ್ಟಿಗೆ ನಾವೇನಾದರೂ ವೀಲ್ಸ್ನ ಪ್ರೊವೈಡ್ ಮಾಡಿಬಿಟ್ವಿ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ, ಜಸ್ಟ್ ಯು ಇಮ್ಯಾಜಿನ್ ಹೌ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಮೂವ್ ದಿಸ್ ಆಬ್ಜೆಕ್ಟ್. ವೈ? ಬಿಕಾಸ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ ಸರ್ಫೇಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ರಬ್ ಆಗಲ್ಲ, ಅಂದರೆ ಕೊಲಿಷನ್ ಆಗಂಗಿಲ್ಲ. ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಹಿಯರ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಮೆನಿ ಕಾಂಟ್ಯಾಕ್ಟ್ಸ್. ಐ ವಿಲ್ ಕನ್ಸಿಡರ್ 1 2 3. ವೀಲ್ ಮೋಷನ್ ಆದಂಗೆಲ್ಲ ಈ ಕಾಂಟ್ಯಾಕ್ಟ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಈ ವೀಲ್ ಮೋಷನ್ ಆದರೆ ನೆಕ್ಸ್ಟ್ ಕಾಂಟ್ಯಾಕ್ಟಿಗೆ ಬರುವಂತಹ ಪಾಯಿಂಟ್ ಏನಾಗಿರ್ಬೋದು, 2 ಆಗಿರ್ಬೋದು. ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ವೀಲ್ ಮೋಷನ್ ಆದಾಗ ಏನಾಗಿರ್ಬೋದು, ನೆಕ್ಸ್ಟ್ ಬರುವಂತಹ ಕಾಂಟ್ಯಾಕ್ಟ್ 3 ಆಗಿರುತ್ತೆ. ಸೊ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಚೇಂಜ್ ಆದಂಗೆಲ್ಲ ಏನಾಗುತ್ತೆ, ದ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಆಫ್ ದ ವೀಲ್ ವಿತ್ ದ ಸರ್ಫೇಸ್ ವಿಲ್ ಬಿಕಮ್ 0 ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಮೋಷನ್ ವಿಲ್ ಬಿಕಮ್ ಈಸಿಯರ್. ಸೊ ಓನ್ಲಿ ವಾಟ್ ವಿ ಸೇ, ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ದ ಕೈನೆಟಿಕ್ ಆ್ಯಂಡ್ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಅದಕ್ಕೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ದು ಮೋಷನ್ ಈಸಿ ಆಗಬೇಕಂದ್ರೆ ನಾವೇನು ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀವಿ, ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ದು ಮೋಷನ್ ಈಸಿ ಆಗಬೇಕಂದ್ರೆ ವಿ ವಿಲ್ ಪ್ರೊವೈಡ್ ದ ವೀಲ್ಸ್. ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಇಟ್ ಫಾರ್ ಮೆನಿ ಲಗೇಜ್ ಬ್ಯಾಗ್ಸ್ ಏನು ಪ್ರೊವೈಡ್ ಮಾಡಿರ್ತಾರೆ, ವೀಲ್ಸ್ನ ಪ್ರೊವೈಡ್ ಮಾಡಿರ್ತಾರೆ, ಸೊ ದ್ಯಾಟ್ ಯು ಕ್ಯಾನ್ ಪುಲ್ ದ ಬ್ಯಾಗ್ಸ್ ವೆರಿ ಈಸಿಲಿ. ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್. ಟು ಮೇಕ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಕ್ಲಿಯರ್ಲಿ, ಐ ವಿಲ್ ಶೋ ಯು ಆನ್ animation now.
You can observe in this animation clearly, here is a boy rolling the object. He is not moving it, he is rolling. Rolling ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಅಲ್ಲಿ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ ಸರ್ಫೇಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಯಾವಾಗ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ ಸರ್ಫೇಸ್ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ದ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ in contact with the surface will become 0. As it has become 0, ಏನಾಗುತ್ತೆ, the object will not rub with the surface. ಅಲ್ಲಿ ರಬ್ಬಿಂಗ್ ಆಗಲ್ಲ. ರಬ್ಬಿಂಗ್ ಆದಂಗೆಲ್ಲ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಫ್ರಿಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಹಿಯರ್ they are rolling the object. As it goes on rolling, the motion will become easier. ನೀವೇ ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿರಿ, ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ ಸಿಲಿಂಡರ್ಸ್ನ ರೋಲ್ ಮಾಡ್ತೀರಾ ಅಥವಾ ಸ್ಲೈಡ್ ಮಾಡ್ತೀರಾ ಅಂತ. ಇಫ್ ಯು push it, I mean if you slide it, you have to apply more force. ನಿಮ್ಮ ಮನೇಲಿ ಸಿಲಿಂಡರ್ ಸಪ್ಲೈ ಮಾಡೋರು ಕೂಡ ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ, ಸಿಲಿಂಡರ್ನ ರೋಲ್ ಮಾಡ್ತಾ ಬರ್ತಾರೆ. ಸೊ ದ್ಯಾಟ್ ದೋ ದ ಸಿಲಿಂಡರ್ ವೇಟ್ ಈಸ್ ಮೋರ್, ಯು ಕ್ಯಾನ್ ಮೂವ್ ದ ಸಿಲಿಂಡರ್ ವೆರಿ ಈಸಿಲಿ ಇಫ್ ಯು ಆರ್ ರೋಲಿಂಗ್ ಇಟ್. ಒಂದು ವೇಳೆ ನೀವು ಅದನ್ನು ಸ್ಲೈಡ್ ಮಾಡ್ತಾ ಬಂದರೆ ಯು ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ಮೋರ್ ಫೋರ್ಸ್ ಆನ್ ಯುವರ್ ಹ್ಯಾಂಡ್ಸ್. ಅದೇ ನೀವು ರೋಲ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಷ್ಟೊಂದು ಫೋರ್ಸ್ ಹಾಕೋ ಅವಶ್ಯಕತೆ ಇರೋಂಗಿಲ್ಲ. ಯಾಕೆ ಅಂದರೆ ಇಫ್ ಯು ಮೂವ್ ದ್ಯಾಟ್ ವಿಲ್ ಬಿಕಮ್ ಸ್ಲೈಡಿಂಗ್ ಮೋಷನ್ ವಿಚ್ ಈಸ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಇನ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಈಸ್ ಗ್ರೇಟರ್ ಕಂಪ್ಯಾರಿಟಿವ್ಲಿ ಟು ದ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್. ಯಾಕಂದರೆ ಅಲ್ಲಿ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ ಸರ್ಫೇಸ್ ವಿಲ್ ರಬ್ ಈಚ್ ಅದರ್. ಸೊ ಯಾವಾಗ ರಬ್ಬಿಂಗ್ ಆಗುತ್ತೆ ಆವಾಗ ಫ್ರಿಕ್ಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅದೇ ನೀವು ಸಿಲಿಂಡರ್ನ ರೋಲ್ ಮಾಡಿದ್ರಿ ಅಂದರೆ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ ಸರ್ಫೇಸ್ ಏನಾಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಆ್ಯಸ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ ವೆಲಾಸಿಟಿ ಕೂಡ ಝೀರೋ ಆಗಿಬಿಡುತ್ತೆ. ಆ್ಯಂಡ್ ದೆನ್ ಯು ಕ್ಯಾನ್ ಮೂವ್ ದ ಆಬ್ಜೆಕ್ಟ್ ವೆರಿ ಈಸಿಲಿ ಇಫ್ ಯು ಆರ್ ರೋಲಿಂಗ್ ದ್ಯಾಟ್. ಅದಕ್ಕೆ ಸಿಲಿಂಡರ್ ಸಪ್ಲೈ ಮಾಡೋ ಪರ್ಸನ್ ಕೂಡ ಏನು ಮಾಡ್ತಾನೆ, ಆ ಸಿಲಿಂಡರ್ನ ರೋಲ್ ಮಾಡ್ತಾ ತೊಗೊಂಡು ಬಂದು ನಿಮ್ಮ ಮನೆಗೆ ಡೆಲಿವರ್ ಮಾಡ್ತಾನೆ. ದಟ್ಸ್ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಇನ್ ಯುವರ್ ಡೈಲಿ ಲೈಫ್. So this is about the rolling friction and kinetic friction. So I hope you have understood the rolling friction and kinetic friction of today's class. Thank you.